Hello everyone. I am Appalnadu Saketi and welcome to video presentation on malware classification with AWS SageMaker. In this short video, I will be walking through the technical details of my project and demonstrating the implementation of all three tasks. And the task the all three tasks will be like deploying the model trained for lab 5.4 as an API endpoint on AWS SageMaker. Then the second task will be develop a Python client which takes in an executable file and extracts the relevant features and retrieves classification results from the SageMaker endpoint. And the final task will be randomly select 100 malware and 100 benign samples from the given EMBER 2019 dataset. Then we will go through benchmark the performance of our deployed model on those samples. Now let's walk through the task one, that is our training the model and deploying deploying our model into AWS SageMaker. So when it comes to model training, we have experimented with various machine learning algorithms, including random forest, gradient boosting, and deep learning architectures. To build our classification model, we fine-tuned hyperparameters and evaluated model performance using cross-validation techniques to ensure robustness and generalization to the unseen data. So now let's talk about our model training workflow. See, let's we have in this training workflow, we have given our sample data as benign executables and malware executables. On training, it will be it will be training as these data as samples. Once after training successfully completed, we are getting our predictive model by using machine learning model random forest classifier. After that, after getting our predict model, we have given an unknown executable file, which will be processing by predictive model. Then we will get a results as malicious or benign. That's what about training our model. Now let's deployment on walk through our model deployment on AWS SageMaker. So once the model was trained and validated, we deployed it as an API endpoint on AWS SageMaker. After that, this will be allowed us to leverage the scalability and reliability of cloud infrastructure for real-time inference tasks. We configure the endpoint to handle incoming requests, perform feature extraction from the executable files, and return classification results to the client. So that's what about the theory, how deployment on AWS SageMaker. So the following diagram shows the preceding workflow, how the AWS SageMaker will work. Meantime, we have deployed our model into AWS SageMaker. So first we have trained our model, right? So trained and deployed our model, right? So the workflow will be model artifacts stored in an Amazon S3 bucket. Then we can go through create an Amazon SageMaker model. After that, we have to choose a SageMaker inference option. Then we have to create a Amazon SageMaker endpoint configuration. Then we can go through create an Amazon SageMaker endpoint. Then we need to invoke the endpoint to get inferences to predict our results by using our train and deployment model. See, that's what about training and deployment of our model. Now let's talk about task two, that is that is Python client development. See, this is our before going to the Python client development, we have to see our training and deployment Python code. See, this is what our trained and deployment Python code I have developed in uh, no, Amazon Notebook instance. In this we have these are the dependents which we are need to develop this Python script. Uh, in the following lines, we have defined a pipeline of sequential transforms, passing vectors, and to extract n-gram features and construct feature vectors from the DDL inputs and section names extracted to the each sample. So this is what about combining the binary n-gram features. Then after that convert after converting after convert training features to pandas data frame, we have to save our training features to CSV. Then we will go through this is what about converting testing features to pandas data frame. Then we have to save testing features to the CSV. Now both extend data frame and test data frames are pandas data frames containing our features. We can use them for further analysis or processing as needed. This is what about our training trained model, that is random forest classifier. This is our machine learning model which is random forest classifier. See, after training our model that is random forest classifier, we have got a training accuracy that is 0.99 percentage. After that, we have to generate features vectors for the test samples. uh, this is what about the Python script about generate feature vectors for the test samples. These are the test samples. Yeah, here you can see what happened. Then we can go through the deployment script. This is our after training our model, we have to deployment our model as an API endpoint. This is our deployment in Python script. See, we have connected SageMaker and we have given our model name and everything, and we have uploaded our data into S3 using Boto3 Python library. So this is what all about our deployment Python script. So once we have running this code successfully, we have deployed our model into AWS SageMaker. Then this is what about our task one part training and deployment the our model as a random forest using random forest machine learning model. After that, we will walk through the Python client deployment. The task two is a Python client deployment, right? So this is the Python client deployment Python script. So now let's talk about Python client. I have developed a simple Python script that takes an executable file as an input, extract relevant features, and sends a relevant to the SageMaker endpoint to classify the file, which is like malware or benign. So let's walk through our Python script. So these are the dependencies. These are the required libraries which we have used in this developed script. Once this is the page to extract relevant features from given executable file. Then then after given our Python a sample Python file path and endpoint URL, this will be classified the given executable file using the provided SageMaker endpoint. So uh, it will be classification. The classification results will be like 1 for malware and 0 for benign. If none of the above, it will be given a results as on if the classification is file returns none. So after extra features from the input file, this is what about extra features from the input file, and this is preparation for the request payload. After that, this is what about sending a post request to the SageMaker endpoint. So after doing all this script, we will get a results once we have given a sample Python sample file, which are like malware or benign, whatever. If you want to give, you can give the results. The results will be classified as malware or benign. So in this I have given a sample file that is a malware. This Python script given classified result as a malware file. See how the result will be obtained here. This is what about task to Python script, developing a Python script. Now let's talk about task 3, that is benchmark that is benchmarking the model performance, right? So let's go to our task 3, benchmarking the results. See here are malware samples results. Finally, let's discuss benchmarking the model performance. The model achieves high precision and recall, indicating its effectiveness and indifference between malware and benign samples. See how the model achieves high precision and recall rates. Okay, these are the recall, and these are the true negative 95 and false positive 5, and precision is 0.95 and recall is 0. Mostly we got a uh, high precision and recall rates, right? So mm, that's what about our results. Results analysis. However, further analysis is needed to understand its behavior in in diverse data sets and potential vulnerabilities to adversarial attacks. Now, that's what about task 3, benchmarking the results. These are our benchmarking performance results. We can observe malware samples like true positive 90, false negative 10, and the precision is 0.9 90, and recall is 90. This is one of our malware samples. When it comes to benign samples, these are the true negatives, false negatives, and precision recalls. Mostly we got high performance only. uh See, one after demonstrating the benchmarking results, our model demonstrates high precision and recall rates, indicating it affectionate. We have already go through all these things, right? So that's what about task 3, benchmarking the results high performance. Now I have to show my GitHub profile what I have done everything. I have uploaded in my GitHub account. I have shown here. Just see, this is my GitHub profile. I have uploaded everything what I have done for this project. So this is a Python script for training and model deployment as an API endpoint. And this is the file which indicates testing or EMBER datasets. This is a project report. If you want mm, more information about our project, what I have done, everything I have included in this report, you can see. And yeah, this is our Python client, which we have already discussed about how Python client worked. Then these are the requirements file in this while while developing this project, we need to have some requirements, right? Some dependence Python libraries. I have included what the requirements we need to install while doing this project. So these are the requirements of Python. See, once if you want more about my project, you just go through my readme file. This is our readme file. See, this is what about my introduction about malware classification with AWS SageMaker, and what table of contents I have given in my project report. And I enter this project, the setup, how you can set up and everything, how to install dependencies, and everything. You just want to download my project. You just clone this repository, and how deploy model on SageMaker. Everything I have mentioned here. You can walk through these README file. You will get everything. So that's what about my project. That is a malware detection classifier as an API endpoint using Amazon SageMaker. Thank you. By conclusion, I have to tell something. That is, my project demonstrates the power of cloud computing, ML and cloud computing. Computing in cybersecurity by deploying a trained model on AWS SageMaker. I have shown we can classify malware with high accuracy and efficiency. Um I hope my project I hope my project I hope this sorry I hope this presentation has provided valuable insights about my presentation work for your own project reference. Thank you for watching. Signing off, Appalnadu Saketi. Thank you very much to everyone.